Have you ever just wondered about the magic that happens between having a great idea for an app and actually seeing it pop up on your screen? Well, in this explainer, we're going to pull back the curtain on the whole world of programming and show you exactly how it's done, from the ground up.
It really all boils down to this one question, right? We're going to follow that journey step by step, from a simple concept all the way to a working application. You'll see it's a really logical process, and by the end, that transformation won't seem like magic at all.
So here's our game plan. First, we'll tackle what programming actually is. Then, we'll get into the core building blocks, the Legos of code, if you will. After that, we'll look at the path to making an app, learn about hunting for digital bugs, and finally, talk about the different levels of programming languages you can choose from.
Okay, so what is programming at its heart? It's way more than just typing weird symbols into a black screen. At its core, it's really the science of dealing with data. Almost everything a computer does, from playing a video to sending an email, is all about processing information.
Let's break that down. You can think of programming as just giving a computer a very precise to-do list. These instructions tell it exactly how to take in some information, say a name you type into a box, do something with it, and then give you a specific result.
And this quote just hits the nail on the head. It doesn't matter if you're building a massive online game or a simple calculator app. Fundamentally, you're just organizing and manipulating data to get something done. That's the big secret right there.
So how does this all work in practice? Well, just like any language, programming has its own vocabulary and its own grammar. Let's look at the absolute core building blocks you'll use to write those instructions.
First up, we have the variable. This is, without a doubt, one of the most fundamental concepts in all of programming. You just have to think of it as a little container in the computer's memory that you can slap a name on. You use it to hold onto a piece of info you'll need later on, like a player's score or today's date.
And you know, here's a fantastic way to picture it. A variable is just like a labeled cardboard box. The label on the outside is its name, like player name, and whatever you put inside the box, well, that's its data. This simple idea makes the whole computer memory thing so much easier to get your head around.
Okay, next we have the instruction. This is basically a single line of code that tells the computer to do something. Take a look at the example here. It's telling the computer, hey, go find the box labeled number 1 and the box labeled number 2, add their contents together, and then stick that result in a new box called answer. See? It's just a simple command.
Now this is where things start to get really powerful. We've got the class. A class isn't a thing you can touch or see in your app. It's the blueprint. It's the master plan that defines all the details and all the actions for a certain kind of thing, like what every button on your screen should look and act like. And if the class is the blueprint, then the object is the actual house you build from it. An object is a real specific thing that you create using that class template. So every single button you click on a website is its own unique object, but they were probably all built from the very same button blueprint.
And this slide shows it perfectly. Look on the left. You've got one single blueprint for a button. It says what color it is, what text it has, what happens when you click it. Then, on the right, you have a bunch of unique individual buttons, all created from that one plan. One's a blue submit button, another is a red cancel button, but they all share that same DNA.
Okay, so we've got our building blocks. Now, how do we actually put them together to build an app? Well, we follow a kind of recipe, and it's called the program development cycle. It's the step-by-step process every developer uses to take an idea and turn it into a real, finished product. This cycle has 5 key stages. You start with project creation, which is just setting everything up. Then you move into design, where you figure out how the app will work and look. After that, you get to the heart of it, coding, where you actually write the instructions. But code is never perfect on the first try, which leads us to debugging and testing, the all-important hunt for errors. And finally, when it's all good to go, you deploy it, sending it out into the world.
Let's zoom in on that 4th step, because honestly, it's a huge part of being a programmer, hunting for those digital bugs. See, making mistakes isn't a failure in programming. It is an absolutely normal, expected, and even crucial part of the process.
And you should know, not all bugs are created equal. They usually fall into 3 main categories. And believe me, knowing the difference is the key to squashing them.
All right, let's look at the 3 types. First, you've got the design time error. This one's easy. It's like a typo that your spell checker catches for you right away. Then there are runtime errors. These are a bit more serious. They happen while your app is actually running and can cause the whole thing to crash. But the sneakiest of them all is the logic error. The program runs perfectly, no crashes at all, it just gives you the wrong answer because the thinking behind your instructions was a little off.
And finally, let's talk about the languages themselves. You might be surprised to hear that they come in different levels. All that means is how close the language is to human English versus how close it is to the raw ones and zeros the computer hardware actually understands.
So here's the main difference. High-level languages are kind of like building with pre-made blocks. They're way easier for us humans to read and write, which lets you build apps super fast. Low-level languages, on the other hand, are more like working directly with the wires and circuits. They're more complex, but they give you incredibly precise control over the hardware itself.
So why do so many people start with and stick with high-level languages? Well, for one, their syntax is just a lot friendlier and more like plain English. This allows for what we call rapid application development, or RAD, which is a fancy way of saying you can build things and test ideas incredibly quickly. Plus, they're super versatile for making just about anything you can dream up.
But here's the really cool part. You don't always have to choose one or the other. Modern programming has these amazing bridges built right in. A feature called p/invoke lets a simple, high-level language call on the raw power of a low-level one when it needs to. So you really get the best of both worlds, speed and power.
So, to bring it all home, programming is really the art of using those basic building blocks, like variables and objects, and following that structured development cycle we talked about, all in the service of solving a problem in a creative way.
It's this awesome mix of creativity grounded in pure logic. It's all about turning an idea into reality with a set of precise instructions. And now, you know the blueprint for how it's done. So the only real question left is, what problem are you going to solve first?